Students, today we start problem number 8, exercise 9.3 NCERT book, class 12. So, differential equation, formation of differential equation. Now, we consider this problem. Form the differential equation of the family of ellipses having foci on y-axis and center at the origin. So, we consider this figure. Foci y-axis means this figure just like this. This is our focus, and here another focus we get. This is foci. So foci on y-axis means this is our figure, and the equation will be changed. So solution: the equation of the family of ellipses having foci on y-axis is x square by b square plus y square by a square equal to 1 and a greater than b. This is our equation. So this is the equation of ellipse. If the foci on x-axis, then this will be x square by a square, y square by b square. Just this will be changed. Now here how many constants we have? Two constants. So you have to differentiate two times. By differentiate two times, we remove anyhow these two constants. After removing this constant, we get an equation. This is called differential equation. Now we differentiating both sides. Differentiating both sides of 1 with respect to x, we get 1 by b square constant ddx of x square, 1 by a square constant ddx of y square, and ddx of 1. We get this. 1 by b square, this is twice x. 1 by a square, this is if we write directly 2y dy dx, this equal to 0. And dividing both sides by 2, x by b square, y by a square, dy dx means we write y1, y this equal to 0. So this is number 2 we consider. Now we have two constants, we have to differentiate two times. Again, differentiating both sides of 2 with respect to x, we get 1 by b square constant ddx of x, 1 by a square constant ddx of y dash, this equal to 0. If we differentiating both sides with respect to x, we get this. And this will be 1 by b square into 1 by a square. This is product rule. We know the product rule formula, ddx of uv, this is u, ddx of v ddx of u. First function ddx of second function ddx of first function. So this is first, this is second. First function ddx of second function ddx of first, this equal to 0. So this implies 1 by b square, 1 by a square, y double dash. If we differentiate this, we get double dash, and this is y dash and dy dx means y dash, this equal to 0. We get this one. This implies, but what we get, we have two constants, so we have to differentiate 2 times and removing these 2 constants, but both the constants are present. Now do or die, anyhow we remove this constant. This is our main technique. So multiplying both sides by x, we get, if we multiplying both sides by x, we get, multiplying both sides by x, we get x by b square plus x by a square y double dash plus y dash square equal to 0. Y dash square. We multiplying both sides by x. Now we know this value x by b square. What is the value? X by b square. If we taking right hand side this one, this will be minus. So I rewriting this. This is x by b square, and this is y dash by a square equal to 0. From 2, x by b square, y dash by a square equal to 0. This is 2 implies. And x by b square equal to minus y dash by a square. Just taking this one right hand side, we get this. Now putting this value, x by b square, what is the value? Y dash by a square. So we putting this value, y minus y dash by a square, and this is x by a square y double dash plus y dash square equal to 0. So we get this. Now we multiplying both sides by a square. If we multiplying both sides by a square, then a square will be cancelled. We get minus y dash plus x y double dash plus y dash square equal to 0. If we multiplying both sides by a square will be cancelled. We get y dash minus y dash x this, and this one multiplying by x y double dash x y dash square equal to 0. Now this is highest order. We write down first x y double dash, and this one second we write x y dash square and minus y dash equal to 0. So at last we get this one x y dash double dash plus x y dash square, this one, and minus y dash. So this one we get, or we can write this is, we can give bracket also, this whole square, which is the required differential equation. Which is the required differential equation? By the help of this equation we get, this is the, by the help of the given relation we get this equation, and this is called the required, which is the required differential equation. So now we consider problem number 9. 9 number given, form the differential equation of the family of hyperbolas having the foci on x-axis and center at origin. So this is our hyperbola If this is actually parabola, this is parabola, and if they are in angry mood, so this is hyperbola. And foci on x-axis means this like this, and y-axis means this figure will be just like this. So this is our figure. Now solution: the equation of the family of hyperbolas having foci on x-axis is x square by a square minus y square by b square equal to 1. This is number 1 we consider. So this is the family of hyperbolas having foci on x-axis. Now we differentiating both sides with respect to x, we get. So how many constant we have? 2 constants. So we have to differentiate 2 times. So differentiate both sides with respect to x, we get 1 by a square ddx of x square, 1 by b square ddx of y square ddx of 1. Then this is 1 by a square, this is twice x, direct formula. 1 by b square, this is twice y, dy dx equal to 0. And 2 is common, 2 cancel. 1 by a square into x, 1 by b square into y, and dy dx means y dash equal to 0. This is number 2 we consider. So we have 2 constants, we have to differentiate 2 times. Again, differentiating both sides with respect to x, we get 1 by a square constant ddx of x, 1 by b square constant ddx of y dash. We get this. Now 1 by a square ddx of x is 1, 1 by b square, this is product of 2 function uv, first function ddx of second function ddx of first, this 1 by a square, 1 by b square, y double dash, dy dash dx means double dash, y dash equal to 0. But our target to differentiate 2 times, anyhow we remove the constants. But both the constants are present. So we have attention how to remove this constant. So our target, do or die, anyhow we remove the constants. So no technique to remove the constants because both the constants is present. Now we multiplying both sides by x. Multiplying both sides by x, we get. So what we get if we multiplying both sides by x, then this will be x by a square, x by b square, y double dash, this is y dash square equal to 0. We get this. But from 2, equation number 2, we get x by a square minus y dash by b square equal to 0. So 2 implies x by a square minus y dash by b square equal to 0, and this one taking right hand side, x by a square equal to y dash by b square. We taking this one right hand side. X by a square, we know the value y dash by b square. This value we know y dash by b square, and this is minus x by b square y double dash y dash square equal to 0. Just we replacing this and putting the value this. Now both the terms we have b square common. We multiplying both sides by b square, and b square will be cancelled. We get y dash minus, and multiplying by x also, x y double dash x y dash square equal to 0. So we get this. This is the highest order. It should be first position, but this is negative. We multiplying both sides by minus sign. If we multiplying by minus sign, then this will be minus y dash plus x y double dash plus x y dash square equal to 0. So we write down this one first, because this is the highest order. It should be first position, and this is x y dash square minus y dash equal to 0. So this is our answer. So x y double dash x y dash whole square and y dash equal to 0. This is the required differential equation, which is the required differential equation. So dear students, these are very nice problem. Solutions are very easy. No one can say the solution is difficult. Just you have to know what is the equation of the ellipse, hyperbola, parabola. This type of problem it was given in first year, ASS first year NCERT book. Just you have to know the formula, and using this formula ultimately answer will come. Just you have to remember how many constant given. If 2 constant, you have to differentiate 2 times, and anyhow we remove the constants. So if you are feeling easy, then please like this video, and if you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.